In the 1950s, nuclear power seemed like a solution to the future, being a sustainable, long-lasting, and a good energy source. The revolutionary discovery of nuclear power took place on the dawn of the 20th century. New Zealand-born British physicist Ernest Rutherford is considered to be the father of nuclear physics. Rutherford was born in 1871. He studied at Havelock School and then Nelson College. In 1895, Rutherford was awarded an 1851 Research Fellowship from the Royal Commission for the Exhibition of 1851 to travel to England and study at the University of Cambridge's Cavendish Laboratory. Rutherford started to experiment with radioactivity. Rutherford traveled to Canada in 1899 and continued his research there. Canada is where Rutherford discovered the theory known as half-life, the radioactive decay of isotopes. This discovery marked the beginning of a new era, an era of nuclear weaponry and nuclear power.
Nuclear power was researched and tested after the discovery of the half-life of uranium, but the power was not harnessed until the formation of the Manhattan Project in 1939. The Manhattan Project produced the first nuclear bomb to be tested in the Trinity test, as well as Little Boy and Fat Man, which were dropped on the Japanese cities of Nagasaki and Hiroshima. The results were devastating. In Hiroshima, over 80,000 people died from the explosion, and in Nagasaki, 40,000 people. Tens of thousands more died afterwards from exposure to radiation. These atomic bombs were the first to be dropped on humans and hopefully the last bombs to see action.
The power of the future, also known as nuclear power, is not as complex as it may seem. Nuclear power is created through fission and fission reactors and fusion and fusion reactors. The way fission reactors work is they take a neutron and fire it into a uranium rod, splitting an atom, giving off energy, and more neutrons to be released, and in turn splitting more atoms, continuing the path of atom splitting. In 100% pure uranium, this would be the making of an atom bomb, so therefore reactors only use 5% pure uranium and also use a buffer of sorts made of less reactive materials to slow down the reaction. The other type of reactor used to make energy is known as a fusion reactor. Fusion reactors use magnetism to force hydrogen plasma to compress and fuse into heavier elements, giving off more energy with less radiation and in a much safer way than fission. Although currently there are no working fusion reactors, ITER is building the first one in France, and it will start producing power in 2027. Unfortunately, nuclear power has also had some drawbacks. On April 26, 1986, the nuclear power plant at Chernobyl in Russia experienced a power surge, and when they tried to stop the meltdown by doing an emergency shutdown, an even bigger power surge occurred, causing steam explosions and a reactor vessel rupture. This exposed a graphite moderator to open air, igniting it. 60% of the fallout that went around Europe and the Soviet Union landed in Belarus. The countries of Russia, Ukraine, and Belarus were burdened with having to clean up and decontamination tasks of Chernobyl. 31 instant deaths are attributed to the failure, while an estimated 4,000 are expected because of the aftermath. This failure is thought to have caused a total of 5,000 cases of cancer throughout Europe. Reactor 4 suffered a catastrophic power increase, leading to explosions in its core. This dispersed large quantities of radioactive fuel and core materials into the atmosphere and ignited the combustible graphite moderator. The burning graphite moderator increased the emission of radioactive particles carried by the smoke, as the reactor had not been encased in any kind of hard containment vessel. Nuclear power is a major source of energy in the U.S., supplying nearly 20% of our power from 100 reactors, also supplying 30% of the world's nuclear power with a total of 807 billion kW per year.